Swayam Prabha. Digital India. Educated India.
Hello, good afternoon. Welcome to the course on comprehensive view of speech processing. This is in the lecture series, this is the sixth lecture. So, in the last class, we were discussing about the acoustic phonetic representation of sound units, and in last class, we basically discussed the acoustic phonetic representation at a sentence level. And today we will continue that. So, in last class we are discussing about how the time and time frequency representation of a speech for a given speech utterance. And here if you see in this figure, it's a speech corresponds to a sentence should we chase, and here in this figure there are two subplots. So, the bottom plot is the time domain signal of a speech, and whereas the top one is this corresponding spectrogram. So, here if you see from this, this is a speech utterance plotted and is a 1 second duration of a speech signal, and this speech signal corresponds to a phrase should we chase, consists of 3 words. If you look at its time domain characteristics, it is very almost you can clearly say that the portions corresponds to unvoiced, and portions corresponds to silence, and portions corresponds to voiced. Here you can see that the initial portion is a bit unvoiced, and then we have a voiced region, and followed by again there is some unvoiced region, then again voiced region, and then again the unvoiced, then voiced, then we have like again unvoiced, and then here finally we have silence, and again at the beginning we have some silence over here. So, from the time domain signal we can able to make out or we can able to distinguish or identify only voiced, unvoiced regions and silence portions of the signal. So, beyond that it is very difficult to discriminate which sound unit it corresponds to. It is difficult to identify from a time domain signal, and whereas from in the spectral domain, or you can say in a frequency domain, you can have some more details you can able to observe, and here at a sentence level you can have lot of information that can be observed from the spectrogram of the speech signal. So, here as I mentioned, the spectrogram is the 3-dimensional plot, so plotted in a 2 dimensions. And here the horizontal dimension is the time, and the vertical dimension is the frequency, and then the third dimension is represented in the form of the darkness, or you can say that the gray color of the signal that is presented over here and all. So, if it is a white, it indicates that the energy is very low, and if it is a darker one, it indicates the energy is a maximum, or energy very high energy. And from this it is observed that at a different time instance what are the frequency components that are present in the signal, and those frequency components what is the energy that is bearing those frequency components. So, that is observed from this, and this is a wideband spectrogram, because the way you can tell it is a wideband spectrogram because you can able to observe here the vertical striations in the spectrogram. So, therefore, you can say that it is a wideband spectrogram, and so, in the wideband spectrogram you can able to see these striations in the vertical direction indicating the pitch periods corresponds to the time domain signal, and here as we see the speech utterance is should we chase. So, the initial sound will be sh, so that is reflected in the spectrogram as the energy that is concentrated at the high frequency, right, and then followed by U. So, you can able to see that the format structure over here, there are 3 distinct formats you can be observed. Then afterwards we have the D, that is it is a like voiced consonant, correspondingly you can able to see a low noise, very low frequency energy is completely concentrated at a very low frequency, and at other than the low frequency you did not see any energy here in the remaining portion. And then should V, where V is like it's known to be diphthong. So V is it is formed due to a combination of two vowels like U and E. A combination of U and E that forms a, the diphthong, or you can say that gliding syllable known to be like V. So that you can clearly see from this spectrogram. So here the initial portion corresponds to vowel U, where only low frequency content will be there, and immediately that follows the E will be there. The combination is a V. We do not see actual separation. It is like both U is influenced by E, and at the same time E is also influenced by U. So therefore you can see that initial portion will have very low frequency content and there is no other frequencies, and afterwards when it reaches to E, so where we have a low frequency content corresponds to the format 1, and the next frequency, the next higher frequency will be very high. It is close to about slightly more than 2000. So this is the characteristic of the front vowel E. We will see the details later in the slide. So that is the reason that from U to E there is a transition of this spectral energy. You can clearly see that from low frequency to high frequency, this transition or this dynamic change of the frequency, the energy distribution in the frequency, you can clearly notice this is because of the presence of a diphthong over here. This is should V, this is the V, and then afterwards you have chase is the word. So for that chase, initially there will be some slight silence will be there, cha, because there is a complete closure. So then afterwards chase, cha is like it's a, you can see that that particular one, cha is a complete closure, then sudden release of that. You can see a noise at a high frequency, and immediately it follows the vowel A. So therefore even this high frequency also, the noise also influenced by this vowel. So that is the reason that you can see that higher formats of this vowel, they can slightly, you can see their traces are observed in the even in the noise, even in the this noise cloud also. So and this is A, and then immediately after following that again we have like chase. So again we have energy at a high frequency. This is due to the sound unit z, z, z. So that way from the spectrogram you can see slightly more details about the sound units. And so with this information in the following slides we will discuss about what will be the acoustic phonetic characteristics or representation in a time and frequency domains for a individual or the groups of sounds. We will see one after another. Yeah. So again this plot is the same time domain plot of the previous speech utterance should we chase, and for visualizing the more finer details of the time domain signal, so it was expanded by taking the 0.8 milliseconds of that signal. That means removing the initial silence and final silence part of that. The remaining 0.8 seconds of the signal has been taken, and it was splitted into 8 parts, each having 100 milliseconds, and now it is plotted one below the other. So you can see that there are 8 plots over here, right, and each corresponds to 100 milliseconds. So therefore it is a 0.8 seconds, and here you can clearly see the more finer details structure of the signal can be observed over here. Here the speech utterances should we chase. You can see the characteristics of individual sounds, like initially it will be like sh. So therefore you can able to see a random noise, it can be observed in the time domain signal, sh, then followed by u. It's you can able to observe a periodic pattern corresponds to the vowel u, and then afterwards there is followed by da. Da is again it's a voicing is there for this particular sound, but it's not, the oral cavity is not vocal, opened, it is completely closed. So, because of that, whatever the voice excitation was there, so that was observed at very low amplitude, because it is not open, the oral cavity is not open, that is a complete constriction, and because of that the vocal folds vibrates still. So, with that there is some energy that will be emitted from the muscles. So, therefore, you can able to see a periodic signal, but it is very low amplitude compared to the above the proper voiced speech. So, this corresponds to the da, and again V is a diphthong as I mentioned. So, you can able to see that for the V, as I mentioned, that it is a combination of U and E. So, for both of them are vowels. So, therefore, you can able to see a periodic structure corresponds to the diphthong V. Then afterwards there is a chase is a word, and for the chase initially here you can see the cha, for the utterance of chase you have the immediate silence is there. It is nothing but the vocal folds are completely closed, the vocal tract is completely closed at a palate cha, at a hard palate, and there is no vocal folds vibration. So, therefore, you can see almost like a no activity. Then the release of that particular constriction produces a turbulence of noise. So, that you can able to see as a random fluctuation in the signal, that is a cha, and then afterwards there is a vowel follows that a. So, you can able to see a clear vowel, and here in this periodic structure also you can able to see some like fluctuations, very random fluctuations here at the peaks. So, this is because of the influence of this cha, right, and then afterwards we have the again za was there, there is again random fluctuations, but here the amplitude of these random fluctuations are very low. So, you cannot observe over here. So, that way the speech utterance should be chased for observing the more detailed structure in the time domain. You can see this particular zoomed version of the signal in a horizontal direction, where you can clearly notice whatever the sounds that are present over here, the corresponding behavior or corresponding characteristics can be observed from this signal. Yeah, the next one here is that as we have seen so far, we discussed about this time domain and frequency domain representations or the details with respect to a sentence, and now the later on we will see that this time domain and frequency domain signals with respect to the individual sound units. So, before that let us see here a message in a written form, like a speech signal is produced by exciting the time varying vocal tract system with a time varying excitation. So, this is the way the speech is produced. So, all of us we know that, right, and here in this, suppose in this particular text for reading purpose, right, when you read the text for this, if the entire of all words are there, then you can easily read. So, from this, suppose for example, if you remove the consonants, and if you retain just the vowels, you can see that for that part actually I just considered the first few words like a speech signal is produced, and in that I just removed the consonants from this from these 4 words. You can see that if you remove the consonants, just retaining the vowels, from this just by presence of vowels, it is very difficult to make out what that particular message is or what those particular words are. Whereas other way, from the same words, suppose if you retain the consonants and if you remove the vowels, so you can make out from this. If you have a knowledge, if you are aware of the English language, then somehow you can able to make out, like here SP, then followed by CH, then in between 2 blanks, like here also. So, from the you can able to easily fill up the blanks and you can able to make out what this phrase is, right. So, from this what it is inferred here is that a written English or a written language, in this context here say English, where even though for reading or for getting a message from the written text, here there seems to be consonants are more important. Like from the exclusive vowels you cannot make out, or it's very difficult to like form the message or derive the text, whereas from the, if you have a consonants, by omitting the vowel positions, you can able to make out a sentence very easily, right. So therefore from a text point of view, if you want to read as a human, here consonants are important with respect to compared to vowels and all. But whereas if you want to perform a speech recognition either by machine or by human perception, it seems to be vowels are important, because the vowels are produced due to voice excitation, and where you can clearly see the periodic structure in the time domain signal, and as well in even the spectrograms also you can able to observe a steady spectral pattern or a steady format structure is clearly observed in the vowels. So therefore for a speech recognition purpose, that means from the speech to like determining the sequence of phonemes or sequence of sound units. So mostly the machines will make use of the vowels and its characteristics. So from that they will discriminate the sound unit, and it will be useful, or they will, the mostly depends upon the vowels and their characteristics for determining the sound units in the context of speech recognition, right. But because the consonants have very small duration, and in that small duration extracting the relevant features and then determining the corresponding sound units will be a bit challenging. So what here the observation here is that in the context of the written text, where for reading the text the consonants will play an important role, whereas if you want to perform a speech recognition from a speech signal, the vowels will play an important role, because the vowels have a steady vowels will be observed to be steady, and they have slightly longer duration, and even their frequency domain characteristics also very clearly observed, very distinct characteristics are observed across the vowels. So therefore by a machine, if you want to perform a speech recognition, vowels play a critical role, a crucial role in speech recognition compared to the consonants. Yeah. So here this is like the classification of English phonemes, or the sound units that are used in uttering the speech in English language. So if you look at, there are about close to around 50 sound units, and these sound units are known to be like a phonemes, right. And these phonemes are divided into different groups. We can see the vowels at one end and the consonants at the other end, right. And in between we have the diphthongs and semi vowels and nasals. So they have the like they have a characteristics of, because here the vowels means they are steady in nature, and they are produced when the vocal tract is open and steady. At that time the vowels are produced, and whereas these consonants are produced when the vocal tract is closed or very narrowly opened. So that way, if you observe the classification over here from vowels to consonants, here the vowels are observed to be produced when the vocal tract is widely open in general, right. And whereas the consonants here, if you look at the consonants like pa, ta, k and ha or j, whatever, all these consonants, so they for the production of consonants, vocal tract will be closed. So as you move from this to here, the vocal tract here is widely open, and here for the production of consonants you can see that vocal tract is completely closed. So that way they are also known to be stops. Stops means there will be complete closure that results the production of those sound units and all. And now if you see these various groups or various classifications in this English phonemes, so here this is the vowels, and here under the vowel group there are further divided into like front vowels, mid vowels and back vowels, and here this classification is due to like when the vowels are produced, there is a movement of tongue will be there, and the tongue will be like a kind of, it will be folded. So, the tongue hump, that means the folded tongue, its position, based on that the vowels are divided into front vowel, mid vowels and back vowels. If the tongue hump is at the front position, it is known to be the vowels that are produced are the front vowels, and if the tongue hump is somewhere in the middle of the oral cavity, the vowels that are produced are the mid vowels, and for production of certain vowels the tongue hump will go further back. So, that way the vowels are divided into front, mid and back vowels, and this classification of vowels is due to the position of a tongue hump in the vocal tract, right. And you can able to see here the front vowels means E, basically E, A. So, you can observe yourself like when you produce E, where you can able to see the tongue hump almost close to the teeth, E, right. And when you try to produce the vowels like A, where the tongue hump is somewhere in the middle, right. And when you try to produce these vowels like O or U, so where you can see the tongue hump at the back, you can see the U, O, where the tongue hump will be at the back of the vocal tract. So, that way based on that the position of the tongue hump, we can categorize the vowels into 3 broader groups, right. And here because there are different vowels, there are almost around 12 vowels that are present in the English, whereas in case of our Indian languages, the kind of vowels that are used, we may not find all these vowels here, but at the same time the vowels that are present in our Indian languages, they may not be observed, all of them may not be observed in English. So, that way from language to language you have some vowels, some of them are present in certain language, some of them are not present. And likewise, we have diphthongs over here. You can see there are about total 6 diphthongs that are present in English. Here 4 were mentioned. You can say that I, O, ow. Likewise, we have like a diphthongs means here these are known to be glides, right. So, it is known to be glided syllable. It means it is a combination of 2 sound units. Like when you say I, it is a combination of A and then followed by E, I. That means you can see for the production of I, the tongue hump starts from middle and it moves towards the front, I. Like in case of O, like in case of ow, where the tongue hump starts from middle and it will go backwards, like because it is like A plus ow, like. So, that way these are known to be like diphthongs, because they are not pure vowels, but they are a combination of 2 vowels, right, very close proximity. So, that becomes a diphthong. At the same time, you can't say that they are the 2 vowels next to next, it is not that way. So, we just mix up the 2 vowels, almost like appears to be like a single sound unit, like ow, like I, like in that way, right. And then coming to the semi vowels. So, here the semi vowels are known to be transients, kind of here also they are also appears like a glide, because you don't see any steady nature in these particular sound units, like a r, l, v, y, like ya, ra, la, va in the Indian context, they are known to be semi vowels, because they are like glides, because they used to be like almost have very transitional characteristics. So, for production of this particular sound unit, the vocal tract will not be in a stable position. The vocal tract will be slowly changing from one position to other position. That transition itself acts like will be observed as a sound unit and all. Like for example, you have a ya. So, you try to see that for the production of ya, where you do not see the vocal tract is in a steady position. Like from beginning to end of this ya means again it is like what ya and then followed by vowel is there, that actual ya or ra, la, like these are the like known to be transitionals or known to be like glides. So, they depends upon the context, the following vowels or the following sound units. Based on that, the vocal tract will be slowly moved, and so therefore, they are not semi vowels. They are neither vowels nor consonants, right? Because they are like appears to be like a vowel, like vocal tract opens, but vocal tract is not steady at all. Vocal tract will be continuously in motion from one position to other position. So, that results to be the semi vowels. Then afterwards we have a nasals. So, these nasals are produced due to nasal cavity. That means, here the resonances are observed or the speech is emitted through the nostrils. So, so that way this group is nasals. Na. So, we know that in our Indian context they are nothing but our in the Varnamala. You can see the next slide, right. So, we have the set of nasals like ma, na. So, all these are the nasals. So, for all these cases where the vocal tract is closed at some place in the oral cavity, and then with that the excitation is coupled to the nasal cavity. So, with that the corresponding sounds are produced, and here the distinction of sounds is based on the position where the vocal tract is closed. For example, in case of ma, where the vocal tract is closed at the lips, the vocal tract is closed at the lips. So, therefore, even though the excitation is coupled to oral cavity, but it will not be emitted, right. So, therefore, the vocal here the excitation coupled to both oral cavity as well as the nasal cavity, but there is no opening from the oral cavity. So, therefore, the speech signal is released from the nostrils, that sound is observed to be released from the nostrils. So, in case of where the oral cavity is completely closed at the teeth, suppose in case of some other where the oral cavity is closed behind that, not teeth, behind the teeth, like at the palate or near the velum, right. So, that way based on the positions in the oral cavity, different nasal sounds are produced, different the constriction, complete constriction takes place in the oral cavity at different places. Accordingly, we have the different nasals. Then we have a stops. We know that we already come across these stops, how they are produced and all. So, the stops are produced due to like based on either complete one thing is that one characteristic is that the vocal tract has to be completely closed, and then if the vocal folds vibrate, then it becomes voiced stops. If the vocal folds won't vibrate, then in that case it becomes unvoiced stops. So, in both the case there are stops because the exhalation of air will be completely stopped, and the release of that happens to be the excitation. But during the complete closure constriction, if vocal folds vibrate, and those sounds are known to be the voiced stops, and if the vocal folds doesn't vibrate, if vocal folds remain open, it is known to be unvoiced stop. So, the examples are like k, t, pa, they are unvoiced stops, and in case of voice the stops are like b, d, g, right. And then the fricatives, and here the oral cavity is not completely closed, the oral cavity is almost closed, but there is a slight narrow opening will be there or at the sides and all. So, with that the air will be rushed, and that acts as excitation and all. So, that is not with that results the sound units are known to be fricatives, and again there are two types of fricatives, voiced fricatives and unvoiced fricatives. So, this voiced and unvoiced distinction is because of the vocal folds vibration. If vocal folds vibration is involved in the production of the sound units, so they are not to be voiced fricatives, because here the vocal folds vibrates, and at the same time the exhalation of air is constrained through constriction with a narrow opening. So, that becomes with that narrow opening the air will be rushed and the turbulence will be generated. So, that acts as a frication, and in that frication if the vocal folds vibrates, that is known to be voiced frication. If vocal folds won't vibrate, then it is known to be unvoiced fricatives. Then the whisper like whisper is a so, where here you can see that in the case of ha, where the vocal folds will not vibrate at all, but here the closure will takes place slightly behind. It is like in the pharyngeal cavity where or near the velum or just behind the velum, the oral cavity tries to close, but there is a slight opening. So, with that the air will be rushed. So, both the whisper and fricatives and all, they remain, they are like similar characteristics, where the exhalation of air will be constricted through a narrow opening, and with that the air will be rushed and that acts as excitation. So, that way in case of whisper, where the constriction or a narrow opening that observed at the behind the velum or in the pharyngeal cavity, right. And then I have affricates like a j and ch, where these are known to be affricates in the context of English phonemes, and these two are also produced due to like a constriction at a oral cavity at different places, at the same place j and ch, but the difference is like one is produced due to during the production of that like excited the vocal folds vibrate, and the other one like in case of ch, where vocal folds will not vibrate at all. Like these affricates are again here, if you want to see the ja is like a voiced affricate, and in case of ch it is like unvoiced affricate. So, this is the way the English phonemes or English sound, the sound units in English language can be categorized based on its place of articulation and the manner of articulation. So, next we just look at the like Hindi sound units, or you can say mostly in the context of Indian languages. So, where in Indian languages we broadly categorize the sounds under the two categories, vowels and consonants, where the vowels are categorized into three groups: short vowels, long vowels and diphthongs. Short vowels, long vowels and diphthong. Short vowels are these are 5 basic vowels: a, e, u, a, o, and the long vowels are nothing but their slightly longer duration of the shorter vowels. Like in case of short vowels simply a, whereas a, e. So, this way the difference between the short and long vowels are the duration of the sound unit, and the moment once it is a long vowel, then we will try to give like more strength to the excitation. So, that way those sound units are observed to be like having more energetic, and intensity is also more, and you can able to see the much darker in their corresponding spectrograms also. And here in the Indian context, we can observe these two diphthongs I and O. These two diphthongs I and O. Whereas in the English, we have seen that there are about 4 to 6 diphthongs in different contexts it will be used. Since it is not our mother tongue, and so therefore we may not pronounce all those diphthongs very effectively. So, that is the reason that actually since based on a mother tongue, whatever the language, whatever the first language we have, whatever the mother tongue we have, so when you try to learn the other languages, so we will try to approximate a certain sound units of the target language in the form of our first language or the mother tongue. So, that way even though in English we have like there are 6 different diphthongs, but we will not clearly articulate all those 6 diphthongs in a very discriminative way, because we are more influenced by our mother tongue. So, whatever the diphthong if you want to utter in English language, we will try to approximate to closer to one of these two all the time, a slight variant of that. Then coming to the consonants, and here our the consonants in the Indian context or Indian languages, they are very much structured, very well structured, and you can categorize these consonants into 2 ways. One is based on the place of articulation, and other one is based on the manners of articulation. So, the places of articulation means here all the consonants we can able to group them into different places of articulation, So, if you look at the velar consonants, where in our Varnamala, if you see that you have a vowels, there are 16 or 18 vowels will be there, and then following that we have the other set of alphabets known to be consonants, and in those consonants if you look at there, you see how they are very nicely structured as per the place of articulation. All these consonants like ka, k, ga, gha, nya. So, all these things you can see, all these 5 of them, if you try to see that they are produced from a complete closure of the vocal tract, complete closure of the vocal tract, right, complete closure of the vocal tract at different places, ka, kha, ga, gha. All of them they are produced by providing a constriction at the velum, that means at the lowermost portion of the vocal tract, velum, right. You can see ka, kha, ga, gha, nya. So, all of them they are produced because of the constriction that happens at the velum, and the release of the constriction at that place, that results these 5 consonants. So, that way these are known to be velar consonants, velar sound units are velar consonants, one way. And then the palatal, it is the constriction next to the velum. I am just moving from the bottom portion or from the inner portion of the vocal tract, there is a velum, that used to separate, that used to isolate the nasal cavity and the oral cavity. So, that is a velum, it is almost like here, and here if you when you try to constrain the air, exhalation of air at a velum, and sudden release of that will produce these 5 consonants, ka, kha, ga, gha, nga. And then the cha, cha, ja, jha, na, cha, cha, ja, ja. So, these 5 consonants they produce due to providing a constriction after the velum, it is known to be palatal. So, we have seen that there are different positions in the vocal tract, there are different places in the vocal tract. By providing a constriction at each place, they result different sound units. So, here you can see at cha, cha, ja, jha, na. So, these 5 vowels they are produced by providing a constriction at a palatal position, and then the ta, tha, da, dha, na, these are the 5 vowels where they provide they are observed, or they are produced by providing a constriction at the retroflex, that means here next to the palatal, that is before the dental, like this one, ta, 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 whereas ta is at the dental. So, before the dental, that is known to be retroflex. So, those at that area will try to stop the exhalation of air, and then sudden release of that air acts as excitation for the production of this one, ta, ta, da, da, da. And similarly for ta, tha, da, dha, na, dental, known to be alveolar, dental, like a ta, tha, da, dha, na. So, for all these sound units, so they produced due to the excitation or due to the constriction at the dental position, will stop the exhalation of air at dental position, and release of that happens to be production of these sound units. Then finally the labial or bilabial, where we will stop the air, exhalation of air at the lips, right, at the lips, and sudden release of that acts like excitation, and that acts that gives you these sound units like pa, pa, ba, bha, ma. And here please note that the sounds here that I just want to mention is the consonants, but here usually consonants will be very difficult to write. They always follow some the vowels in the Indian context. So, that is the reason here we have just mentioned these consonants as consonant followed by vowel. For all these, the consonant followed by vowel a was mentioned. Otherwise, actually here the intention is that the consonant means it is like k, the portion of k, then followed by a it becomes ka, k followed by e it becomes ki. So, likewise we have various sounds, right, various like syllables used to be there, a combination of sounds known to be syllables, right. So, that way here we have here, for the sake of showing that one, here we have mentioned a consonant vowel combination. Otherwise, the consonants are important here. Here the things that need to be observed is a consonant, how the consonants are produced because of the constriction at different places, right. And similarly, you can see the semi vowels also, they are very much structured, like say ya, ra, la, va, ya, ra, la, va, ya. Ya means it is not at a velum, after the velum, that is a palatal, where where you can say the tongue is almost like about to close, ya, ya, ra, la, va. That means here the tongue touches the positions, and there is still a gap used to be there. So with that gap, that kind of the articulatory position provides you the semi vowel and all, ya, ya, ra, la, va, right. And similarly the fricatives, you can see in the context of Indian context, the fricatives are sa, sa, sha, ha, sa, sa, sha, ha. You can see ha, where it is a velar position, where you have a slight narrow opening will be there, ha, sha, that is at a palatal position, and then sa, that is at the retroflex, and sa, that is at the dental position. So if you look at here in the our the Varnamala, where you can say that the Devanagari these are the sounds in the Indian context, mostly are derived from Sanskrit. So you can see the sounds are like, the production of the sounds are very much structured, and they are organized based on the place of articulation. Like the entire Varnamala, you can able to clearly see that the ka, ka, ga, ga, na all are produced from at a velar construction, right. And then cha, cha, ja, jhanna, they are produced at the palatal, and the retroflex is the ta, ta, da, dhan. So you can able to experience your side, you just try to produce those sounds and see that from where the construction is taking place, and that way it will be very clear that, so our entire consonants, all consonants in Indian languages can be divided into 5 groups based on the place of articulation. And similarly, you can also classify the sound units based on their manner of articulation, right. That depends upon here, like unvoiced excitation based on voiced excitation, and nasal, that means the excitation that is coupled to nasal cavity, and semi vowels and fricatives. So these are the manners of articulation, the way the articulators are positioned, and based on that the sound units are produced. In case of unvoiced, the vocal folds remains open, right, and the corresponding sound units are ka, cha, ta, ta, pa. You can see ka, cha, ta, ta, pa. If you observe, you do not find any vocal vibrations. Similarly, the ka, cha, here the difference between ka, cha, ta, ta, pa and then ka, cha, ta, ta, pa. So the difference is that mostly the excitation or whatever the characteristics remain same, but one of them is unaspirated, other one is aspirated. So it means that actually for the production of ka, cha, ta, ta, pa, you have a constriction, complete constriction, and then afterwards the release of constriction happens to be your excitation. But here in case of unaspirated versus aspiration, the pressure that will be built up before release of the constriction, that varies. In case of unaspirated, the pressure that built up will be lesser, whereas in case of aspirated, the pressure that build up for the release of constriction will be very high. So therefore sudden release of that, you can see a sudden turbulation with a very noisy turbulation can be observed. So that forms your aspirated consonants, like a ka versus ka, the difference is that, right. And similarly ga versus gha, the difference is that aspiration, presence of aspiration and absence of aspiration and all, right. So that way in case of voiced consonants, here you can say ga, ja, da, da, ba, so they are the voiced consonants, right, and its corresponding aspirated versions are slightly stressed versions, like gha, ja, da, da, ba, right. And anyway, nasals we know that, you can say that, and here you can see in a Indian context we have clearly we have different nasals are there, like whereas in English we observe that there are only 3 nasals, like ma, na, na, but here we have different nasals are there, like ma, na, you can say ka, ka, ga, ga, na, cha, cha, ja, ja, na, ta, ta, da, dha, na, ta, ta, da, dha, na, pa, 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 pa. So all these are, you can clearly articulate at different places, right, and these are the semi vowels and fricatives. So that way you can see in a Sanskrit language, or you can say that in Indian context, because since most of the languages are derived from Sanskrit, that is why I used mentioned as a Sanskrit, these sound units are very nicely, or very, you can say that systematically like categorized or placed as a part of our alphabets, and they are based on the place of articulation and manner of articulations, very nicely structured the alphabets which are very nicely structured as per the production characteristics. Yeah, you can see here as I mentioned, for production of vowels the tongue hump will play a role, right. So, here you can see there are like a 12 figures over here, and for each of them you can see how the tongue hump is there, whether the tongue hump is at a front position or a tongue hump is at a back position. You can see the tongue hump is at a frontal position, and here for this the vowel that was produced is E. You can say Eve. So, when you say Eve, where you can see that the tongue hump will be at a frontal position, right, and this is a long E like it, and this is hate A, and this is met A like, and this is a father where O, where it's a vowel, a long vowel. So, where you can able to see the tongue hump here you can see, and then you can see the oral cavity is very widely open. It's observed A, right, and whereas in case of E you can see that the oral cavity is almost like very narrow, like you can see, because the tongue hump will be raised at the frontal position. So, with that like the entire oral cavity will be now divided into two parts, like a frontal cavity, that means before tongue hump, and the beneath the tongue hump, that means at the back side of the tongue hump, right. So, because of this tongue hump at the frontal position, because there is the cavity size is very small, so that results a format, the second format having very high, whereas in case of A, where it is very widely open. So, therefore, we have like a 3 or 4 formats where the energy will be concentrated at 3 or different 4 frequency ranges, whereas here in case of E, the significance or the significant difference between E versus other vowels, where you can see as the tongue hump rises at the frontal position, the cavity, the oral cavity which supposed to produce the resonances will be of very small in size. So, therefore, you can able to observe the high frequency energy, that means the energy is concentrated at a very high frequency and all. So, that way you can see the format, the first format and second format, we have a huge difference between in the vowel E, and you can see the other vowels also, like for example boot, U, where the tongue hump is at back, foot, and you can see that for different here it was placed for the utterance of particular vowel in a specific context, in a specific word. When you utter, you can able to notice that how the tongue hump is positioned, where the tongue hump is positioned. So, that way based on the tongue hump position, the vowels are divided into like a front vowel, mid vowel and back vowel. And there is other way of classification also, and based on the height of the tongue hump. If the tongue hump is very high, it is known to be high vowel. If the tongue hump is low, very low, it is known to be low vowel. If the tongue hump is somewhat moderate, it is to be like a mid vowel and all. So, that way based on the position of the tongue hump, we will categorize them as a front vowel, mid vowel and back vowel, and based on the height of the tongue hump, we can say that we can further categorize them into like a high vowel, mid vowel and low vowel. If the tongue hump is very high, then the intensity of vowel will be very high, we can able to notice that, right. And if the tongue hump is low, very low, then the intensity, or you can say that the emphasis that is given to the vowel is also low. Like for example, oo, where the tongue hump is very low, right. And whereas for example, a, where the tongue hump is very high, like E, tongue hump is also very high. So, that way you can categorize the vowels based on the height of the tongue hump also, like high vowel, mid vowel and like low vowel. Yeah, right. And here these are the like the time domain signals corresponds to different vowels. Here you can see the first two vowels corresponds to the first two signals corresponds to the vowel E. One is the short vowel, other one is the long vowel, E and E, and then it's A, and then all these are different forms of A's, because we cannot utter, because these are the phonemes that you can able to observe in English language, and as we are the the some other mother tongue. So, therefore, we may not utter all these phonemes in a very clear way, in a very the exact way and all. Like we have oo, oo, and here you can able to observe that in the E, in the vowel E, where in the time domain waveform you have a low frequency content, and on top of the low frequency content you have some random fluctuation is there. So, this is of the high frequency nature or the high frequency component that is present in the signal. It means it has a low frequency, and on top of that one you have see the fluctuations are there. So, these fluctuations are the result of the high frequency content, right. So, therefore, in the case of vowel E, you have a low frequency content and as well as very high frequency content is also present. Whereas, in case of other vowels like A and A, where there is a low frequency and there is other frequencies also there, but it is predominantly you can able to see in the vowel E. And again, where in case of vowel U, you see that there is a smooth sinusoidal wave kind of a thing. It means only here the low frequency content is very dominating, and we do not observe much high frequency content over here. High frequency content means if we have a fluctuations that is superimposed on this envelope, then you say that there is high frequency content was present, like some significant high frequency was present, but you are not observing that, right. And similarly, in case of O, where again you can see that there is a low frequency content and again some high frequency also present, right. So, this is just like a broad observation from a time domain signals, whereas if you look at their corresponding spectrograms, then you can able to see very clear observation whatever we grossly observed in the time domain signals and all. You can see in case of A, as I mentioned, there are 4 or 5 formats here, like this is the higher format, highest, and this is the next format, and these are the low format, and here you can say that the second format and slightly the bandwidth of the second format, or the range of frequencies at the second format is slightly larger, you can able to observe. And this is the E, the spectrogram for E. You can see there is a low frequency content as we have seen, and then there is a very high frequency content. In between you do not see any other frequencies, that means there are frequencies, but they have very insignificant energy. So, that way, by if you want to discriminate the vowel E from the rest of them, it is very clearly you can say that the F1 and F2, the difference between F1 and F2 is very high in case of vowel E compared to the other vowels. If you look at the vowel U, for example, as I mentioned that the low frequency content is very dominant and you do not see much high frequency content. If you look at U, where the reason for that is for the production of vowel U, you can see that your oral cavity is observed to be like a kind of uniform tube. U, entire oral cavity we just molded or we just made the shape just like a complete tube, just like uniform tube. So, that is the reason that it provides a single resonant frequency or like the low resonant frequency, and other frequencies, multiple frequencies you do not observe that. Whereas, in the remaining other vowels and all, where if you observe the shape of the vocal tract, it is not that simple, it is not observed to be like a uniform tube, it is observed to be like a different structure, somewhat complicated structure. So, because of that the multiple frequencies will be resonated. So, that is the reason that you have multiple frequencies for different vowels, where in case of U, where only the low frequency content will be dominant, right.
In view of speech production, so far we have discussed in the theory about how the various speech sounds are produced with the help of the excitation source and the vocal tract system. And here, for better understanding of the speech production mechanism, so there are animations that are available at the YouTube created, they are available in the YouTube, and you can able to visit these following links, and where you can able to see the animations related to the production of different sound units. So, here you can able to clearly visualize how the various speech sounds are produced, like the vowels, consonants, and again in the consonants there are different types of consonants like voiced stops, unvoiced stops, nasal stops, fricatives. Likewise, each of the sound unit, how they are produced, like for the production of each sound unit, so what is the excitation source and how it is coupled to the either oral cavity or a nasal cavity, and what are the various articulators that are that can be that are part of the production of a particular sound unit. So all those things you can able to clearly visualized by in these animations and all. So in view of that, I recommend to follow these go through these links, and you can able to see the animation videos. So with that you can get a better picture of picture and understanding about the speech production, particularly to different categories of sound units.
We'll stop here.